Hello, in this video we're going to talk about how to multiply complex numbers. So to do this we could think about just how we've multiplied algebraic expressions in the past in earlier sections of Algebra 2 or even in Algebra 1 by just using the distributive property or by FOILing. And if we look at example 3 and 4 here, we do have some special products properties that you most likely learned in Algebra 1. For number 3 here, notice we have the sum and difference pattern. So we could think about, okay, when those are in standard form or like when we FOIL them out, it's going to look like the difference of two squares. And then for number 4, we have the square of a binomial. So that's going to give us a perfect squared trinomial, or we could think about the pattern that we can use to multiply those, okay? So let's look at number 1. We have 15i times the quantity of -1 plus 2i. So here we're going to utilize the distributive property, and we get negative 15i plus 30i squared, right? So now we can think about I squared being -1. So this would be plus 30 times -1. And now we could write this, and I'm going to go ahead and write negative 30 first. So negative 30 minus 15i. All right, and that would be our final answer. So for number 2, we have 4 minus 12i times 11 plus 8i, and we're going to go ahead and FOIL this for number 2. So 4 times 11 would be 44. 4 times 8i would be plus 32i. This would be negative 132i. And then minus 96i squared. Okay, so now we have 44. We could combine our like terms here. So this is going to be minus 100i, and then minus 96, and then once again I squared is -1. So we can multiply that by -1. So 44 minus 100i plus 96. And now we can add 44 and 96, and we get 140 minus 100i for our answer to number 2. All right, so now for number 3, we mentioned a minute ago that this is the sum and difference pattern. So we could FOIL this, but hopefully we remember this pattern from Algebra 1, and essentially our middle terms would cancel out if we FOIL this. So if we remember, if we think about this being like a plus b times a minus b, it's going to give us a squared minus b squared, right? So now, if we think about this pattern, a would be 9, right? So this is going to be 9 squared minus, and then b would be 5i. So this is 5i squared. Well, 9 squared is 81, 5 squared is 25, and then I times I would be I squared. I squared. So now we have 81 minus 25, and then remember I squared is equivalent to -1. So we can say 81 plus 25, and we get an answer of 106. All right, in our last example, number 4, we have the square of a binomial. So once again, this was a pattern. Hopefully you remember this from Algebra 1. If not, you can always just write this as 8 plus 3i times 8 plus 3i and FOIL that out. But remember, the pattern would be a squared plus 2ab plus b squared. Okay, so in this case, a would be 8. So we have 8 squared plus 2 times 8, and b would be 3i. And that's how we could write that out. So now we can simplify. So 8 squared would be 64. This would be 48i, and this would be 9i squared. So now we have 64 plus 48i plus 9, and then once again, I squared is equivalent to -1. So 64 plus 48i minus 9. And now we can combine 64 minus 9, and we get 55. So our final answer would be 55 plus 48i. Okay? And that is how you can multiply complex numbers.